Hello and welcome to the wonderful, newly revised 7.2 Solve and Write Addition Equations. This is going to start on textbook page 525 and we're going to go all the way through textbook page 528. And again, this is my new revised version, so you're going to see some funny little things in between here. Before we get started on this slide, I want to go ahead and show you a couple things that you need to have handy with you now. You want to have a pencil with an eraser because this is how you're going to do all of the on your own problems. That way, if you make a mistake, when you watch the correction portion of the video, you can correct it easily. You also want to have your colored pencils out, highlighters. You want to make sure never to write in highlighter, but you can write in colored pencil or pen. But again, never using colored pencil or pen when you're doing the on your own problems or the guided practice. So now we also see over here on the right hand side your math textbook. You need to definitely have that out and handy and open to the pages that I've described so that you can make sure you're writing your notes in the correct place. Right front and center, you see this pretty picture of the colorful brain because you need to be thinking as you're watching the videos. You can't be distracted watching TV, listening to somebody talk. This has really got to be the focus of your attention right now. And last but certainly not least is your listening ears. It's probably best if you have some headphones out so that you can listen and focus with just the headphones on. Let's go ahead and get started. One more brief thing before we get started. You want to make sure that you write everything, and then more everything. So even if you already know it, even if you can see it right there in the textbook and I write it right next to it, you need to write the same thing. All right, so here we are on textbook page 525. You see two people that are at a miniature golf course, it looks like, because they're looking at a windmill type thing with a golf ball going into it. So let's go ahead and see what that's all about. Before we do that, at the top it says what you'll learn. Scan the lesson and list two real-world scenarios in which you would use addition equations. Now you can either come up with your own or you can use the ones that I'll be providing here. As you can see here, the examples that they've given you say addition equations can be used to find the length of something when you know the total length and the length of the part. So that's pretty important because we're going to see a lot of those word problems with the total length and the length of the part. So total length, length of the part right there. Addition equations can be used to find the weight of something when you know the weight of something else and the difference in the weights. So also another real world example that you will see here. All right, so right away we see the real world link and it says miniature golf. On the second hole of a miniature golf, it took Anne 3 putts to sink the golf balls. Her score is now 5. She represents this situation with cups and counters. Number 1 says fill in the boxes above the phrases below. Above using the phrases below. The first thing says her score on the first hole is unknown. So what they want you to do is go ahead and put that in that box to the left where I've written it there in purple. And they have an empty cup there. The reason they have an empty cup there is because it's unknown. You don't know how many golf balls she got in or how many putts she had on the first hole. Then the next one says her score is now 5. So you want to look at the two boxes that are left. We have the box in the middle that has 3 yellow dots, and we have the box on the right that has 5 yellow dots. So obviously the box on the right with the 5 yellow dots is where we're going to put her score is now 5. So you want to go ahead and do that now like I've done here. Then the last piece says she scored a 3 on the second hole. So we're going to put that in the middle because we see those 3 yellow dots. So as you can see, I went ahead and put she scored a 3 on the second hole in that middle box. So now it says to write an addition equation shown in the figure, or write the addition equation shown in the figure. So what you can see here is x, because that's the unknown, so we're going to use x to represent the unknown, plus the 3 yellow dots in the middle, equals the 5, which her score is now. So you want to make sure that you can construct an addition equation based on a word problem. So that's what we've done here. For number 3, it says explain how to solve the equation. So what we would do to solve the equation is subtract 3 counters from each side. So as you can see, I wrote subtract 3 counters from each side, and then I also wrote the equation again. So I'm also going to show you how we subtract 3 counters from each side. So you have plus 3 and minus 3, which are going to cross each other out, and now you have 2 here. So you have your answer, which is x equals 2, which means that Anne's score on the first hole was 2. So we're going to go ahead and write that right in there. All right, so let's go ahead and get started on this section. Now you should be on textbook page 526. At the top it says solve an equation by subtracting. So remember, we talked about the difference between an equation and an inequality. And so now we're going to talk a little bit about inverse operations. So what I've listed here on this slide is a couple inverse operations that you're already aware of, or opposites: big and small, empty and full, near and far, dirty and clean, open and closed. So inverse basically means the opposite, or to undo something. So if you open a door, you can close it to undo it. If you close the door, you can open it to undo it. And the same thing with pouring out a glass. You can make it empty, or you can make it full again by pouring it out. So when you're thinking about solving equations by subtracting, you want to think about undoing the operation that's being done to the variable. So it says in lesson 1, you mentally solved equations. Another way is to use inverse operations. So that word inverse operations is going to be your vocabulary word, or one of them. And it says which undo each other. So that's a really, really, really important concept right there. So you want to make sure that you write undo. Big words, big letters. For example, to solve an addition equation, use subtraction. So to solve an addition equation, you're going to use the opposite, which is subtraction. So let's go ahead and look at the method so that we can figure out how to do this. It says solve 8 equals x plus 3. And then it says to check your solution. So for method 1, it's talking about using models. So model the equation using counters for the numbers and a cup for the variable. So just like we did with the putt-putt golf scenario, it says 8. So notice we have 8 counters here. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we have the empty cup over here. So what letter did we use to represent the empty cup before? Well, we used x. And then we have 1, 2, 3, and it's going to be x plus 3. Okay, so now it says to remove the counters from each side so that you basically get the cup alone. So I am going to do that now. I'm just going to actually color them out so that they're gone. So we're going to cross those out, and we're going to cross the 3 out there. Scribble, 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 scribble. Okay, so now as you can see, you have the cup, which is x, and then you have 1, 2, 3, 4, 5. So there are 5 counters remaining. So using a model is one way to solve an addition equation using subtraction. Now we're going to focus on the method that we're going to use the most. Now you have some blue writing out to the side on your paper here, but I've erased that. So don't worry about it. You don't need to draw a line through it or anything, but I do want you to focus on the method that I'm showing here. So first, out to the side, I would like you to write the original problem, and that's always going to be my request. So first you want to write 8 equals x plus 3. So that's the original problem. Then the next thing I want you to do is subtract 3 from each side. So when you do that, the subtraction sign needs to be directly underneath the addition sign, and then you need a line. Then when you subtract 3 from the 8, you're going to put a subtraction sign right there, and you're going to draw a line directly underneath the 3. So now, when you add 3 and then you subtract 3, you've basically undone what you did. So the reason we picked this side to subtract 3 from, and the reason we didn't subtract 8, is because that plus 3 was what was being done to the variable, which is x. So that's really the first thing that you look for, is which side is my variable on? Sometimes it'll be on the right, sometimes it'll be on the left. So in this situation, it was on the right, and I had to say, okay, what's being done to x? Well, 3 is being added to it. So now I need to subtract 3 from it. That's how we picked 3 and not 8. So now we're going to go ahead and take 8 minus 3, and we get 5. And it's very important to remember that you need to write your final expression, or your final answer. You can't leave it just like this. So your final answer is 5 equals x. There's no need for you to flip it around or turn it around right now. 5 equals x and x equals 5 means the same thing. All right, so now on the bottom left, I would prefer that you not do the check underneath your answer. So the last piece here is that we're going to also put a box around that 5 equals x. So off to either the left or the right, either side is fine, I would like you to draw a bubble and write the word check. Because now what we're going to do is go ahead and check our solution. To check our solution, we first have to start with the original equation. So that's going to be the same as it's been for every other section. Then we're going to go ahead and substitute our solution in. So our solution is this 5 right here. So now we're going to write the equation just as it is, 8 equals, but wherever we see x, we're going to write a 5 plus 3. Now this lesson should now tie in with 7.1, where you were substituting and telling me if they were solutions for the problem. And the last piece is just going to be to solve both sides, or to solve the side. So you're going to leave the 8 alone, and then you say, okay, 5 plus 3 is in fact 8. and check. That is correct. I do expect to see you check each one of your problems, and it's important that you're actually in your head or even off to the side if they're larger numbers doing the math to make sure that 5 plus 3 is in fact 8. You don't want to just go, okay, yep, check, that's right. All right, so here on this page, you're going to want to write these notes. You can write them in the workspace, you can write them in any blank space that you have on this page, or you can always attach an additional sheet of lined paper so that you can write these notes. But these notes are super, super important. I'm going to refer back to them over and over. I've given you an example problem here, 9 equals x plus 3, and I'm going to go through each step sort of quickly, so you want to make sure you're paying attention. In yellow, I've written the very first thing that you need to do. It says, which side of the equal sign is my variable on? Remember, the variable is a letter. So I can identify my variable, it's x, and it is on the right side of my equal sign. So that's my first step. So now I ask myself, what is being done to the variable? So what I mean when I say what's being done to the variable is I mean what's on the same side as the variable. So right now you can see that 3 is being added to the variable. Okay, so that's what's being done to it. 3 is being added to it. Okay, and so now you can see I've written step 3, which says, how do I undo adding 3? So you would subtract 3 because that's the inverse or opposite. So you would subtract 3, but notice my really important note right here. It's very, 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 very important. Step 4 here says what you do to one side, you must do to the other. Okay, sorry, I fixed that. So what you do to one side must be done to the other side. And by side, I mean the equal sign, because remember, that equal sign is like a wall. So you want to refer back to this slide or these notes very frequently while you're working on your problems. Go ahead and pause the video now, and I would like you to work out the first problem. I do want you to write the problem first and go through each one of those 4 steps. And then the very last piece on this page right here, which I actually forgot to include, was that you need to check your answer. So I'm going to add that right back here, so you need to as well. So let's go ahead and pause the video now. All right, welcome back. So now you can see that I've started with my original problem. I've written it in yellow so that I can keep it consistent with the notes that I just gave you. And so now, since I've written the original problem, I'm now going to show you, I'm going to locate the variable. So the first thing I need to do is locate the variable. Well, I can see that the variable here is going to be c. So now I ask myself, what is being done to c? And by being done to, I mean adding 2. The reason why we're saying 2 is being added and not the 5 is because the plus 2 is on the same side as the c. So now I say, well, how do I undo adding 2? Well, the inverse or opposite is going to be to subtract 2. But remember that golden rule of thumb, do unto others as you want done unto yourself. You want to kind of remember that as well, because what you do to one side, you have to do to the other. So now it's also very, very important that you put a cross through these 2 right here, because plus 2 minus 2, the whole purpose of that was so that you could get rid of the 2, because the entire point of the problem is to get c by itself. So now just below the 5 minus 2 here, you want to make sure that you write your answer here, which is 3, but that cannot be your final answer. You need to rewrite the c equals 3 and then put a box around it. The reason you cannot work from this 3 right here and just call that your answer is because we're going to move forward and you're going to have 2-step equations soon, and so then you'll have to know to rewrite your problem at that time as well. And then the very last piece that you don't want to forget to do is you want to check your work. So check. I like to, if you could put that in a bubble for me so that I can see it. And with the work, we always start with our original, c plus 2 equals 5. And then we substitute. So we're going to, our solution we said was 3, which we got right here. So it'll be 3 plus 2 equals 5. And then we just solve to make sure it works out. 3 plus 2 is in fact 5. So 5 is equal to 5. So now we know that it's correct. Check. All right, so now we're going to go ahead and look here at our next one, B. So it says 6 equals x plus 5. So the first thing you need to do is write the original problem, as I've shown here. The next thing that you're going to do is subtract 5 from both sides. So remember, you want to make sure that you show minus 5 under both of them. It's very important that you write the subtraction sign itself. A lot of people will just write the 5s under there. You're not always going to be subtracting, so it's extremely important to write the minus 5. Then you're going to cross out the plus 5, minus 5, because those are like offsetting each other in football, offsetting penalties. So it doesn't really matter. You haven't moved. So it's the same thing. We got rid of those. And then 6 minus 5 gives us 1. So our final answer here is going to be 1 equals x. There's no need to flip-flop it around. Leave it just as it is and put a box around it. But we're not done yet. We want to make sure that we check our response. So first we're going to write the equation, which was 6 equals x plus 5. Then we're going to plug in our solution, which was 1. So 6 equals 1 plus 5. And then we're going to solve it. 6 does in fact equal 6, so we know our answer is correct. All right, so now we're going to go ahead and look at the next problem. It says 3.5 plus y equals 12.75. So I'm going to start by writing the original equation each time. The next thing I'm going to do is identify first what side of the variable, where is my variable? My variable here is y. It's on the left-hand side. What's being done to my variable? Well, 3.5 is being added to it. Even though you see 3.5 plus y, 3.5 is still being added to the y. So you want to subtract or undo adding 3.5. So when you do that, you will get 9.25 on the right-hand side, and then you want to make sure to cross out the 3.5 minus 3.5. Again, you want to make sure that you're lining up your decimal here because as you notice in green, that lime green color that I have, I've added that 0 for a placeholder to make sure that I don't mess up my decimal placement. Then I'm going to have y equals 9.25, and I'm going to now check my equation. So I'm going to set it up, I'm going to plug it in, and then the very next thing I'm going to do is on the side, notice here over to the left in white that I actually did the addition again. You need to do that to make sure that you're actually checking your problem. Then on this side, on the right, I wrote 12.75 is equal to 12.75, and that is correct. Now we're going to be looking at textbook page 527. So 527 is where you should be looking now. On textbook page 527, you see if you subtract the same number from each side of an equation, the two sides remain equal. So this is one of those properties that we were working with before. So this is the property, the subtraction property of equality. I want you to note that the subtraction property of equality applies to addition problems. So notice the problem is x plus 2 equals 3. And it's actually the subtraction property of equality that says I can subtract 2 from each side and they still remain equal. So it says when you solve an equation by subtracting the same number from each side of the equation, you are using the subtraction property of equality. So for your tests, quizzes, vocabulary, everything, you want to remember that it's sort of like the opposite. If you're working with an addition equation, then you're applying the subtraction property of equality to solve it. Example 2 says Ruben and Tariq have 245.5 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? Write and solve an addition equation to find how many minutes belong to Tariq. So this is, for those of you that did the inquiry lab in class today, this is exactly like the bar diagrams that we were working on today. So Ruben, what you know is that Ruben and Tariq together have 245 minutes of music. Then you're going to let T represent the number of minutes that Tariq has because that's what you're solving for. And you know that in all, they have 245.5 minutes. So as you can see here, I've made the same type of bar diagram that they have. So we have 132 plus Tariq's minutes equals the 245.5. And just like before, we apply the subtraction property of equality. And when we do that, we say, okay, T is, we're adding 132 to each side. Scratch that. What I'm saying is T is the variable. 132 is being added to it. So to undo adding 132, we're just going to simply subtract 132. And once again, you need to make sure that you're paying close attention to that decimal there because 132.0 is probably what I would set it as to make sure that we're solving it correctly. So now we're going to cross that out because those simplify out. And then we have 5 minus 0 is 5. Bring down our decimal. 5 minus 2 is 3. 4 minus 3 is 1. And 2 minus 1 is 1. So now we get a total of T equals 113.5. Then you want to put a box around it. And as you can see, they've also shown you how to do the check at the bottom. So you want to make sure, my apologies, you want to make sure that they have that on both sides. That you have done the check for this problem as well. All right, so you want to go ahead and pause for D, and you want to set up the equation, and then you want to solve it. So I probably, for this one, would also still use a model. It says, suppose Ruben had 147 minutes of the 245 that were downloaded. Write and solve an addition equation to find how many minutes belong to Tariq. So remember, you have to first write the equation, and then you have to solve the equation. And remember, they're also asking you for an addition equation, so you want to make sure that you have an addition equation. So off to the right, I'm going to go ahead and draw a bar diagram, and I'm also going to label it. So remember, the whole bar has to represent 200 245.5 minutes, because that was the total. Remember, when we're working these equations, it's definitely easier to find, or usually easiest to find, the total. So we're going to go ahead and say that that whole bar right there is 245.5. And now we're going to show in this bar that Ruben, in that lime green color, he has 147.5 of the 245 minutes. Then we're going to look at Tariq, and we see that Tariq is going to be right here. So I'm going to make a little lowercase t here to represent Tariq. So now you can see that the equation is sort of panning out for you. You're going to come up with the 147.5 that we got in green plus Tariq, which is in blue, is going to equal the whole bar, which is 245.5. So now what you need to do is say, what's our variable? Our variable is t. What's being done to the t? Well, t is being added to 147.5. So in order to perform the inverse operation, we would need to subtract or undo the adding. So we're now going to subtract 147.5 from this side and 147.5 from this side, because what you do to one side, you must do to the other. You want to make sure that you have written the subtraction sign for each, like I've done here, as well as the line. So now we're going to go ahead and begin to solve. We can cross through this because plus 147.5 minus 147.5 cancels each other out. And so now we're going to do the subtraction here. 5 minus 5 is 0, 5 minus 7. So now we get 98.0, which is also the same as 98. And now what we're going to do is rewrite our answer, because we have Tariq, which is t, all by itself on the left-hand side, equals 98 minutes. Okay, once you've solved that, you want to go ahead and make a little check situation over here to the right so that you can just double check your answer. And as you can see here on the bottom right, I went ahead and made that little checkbox. We've got 147.5 plus t equals 245. That was our original equation. Then we're going to plug in the 98 for the t, because that's what we said. We said Tariq's minutes were 98. And then we're going to solve. 245.5 is equal to 245.5, and that is correct. So we have completed our problem. This is just a little note to remind yourself that you always need to check your work. So you want to make that little check bubble anywhere you have room, just preferably not below the equation. When you're working down an equation, the very last line for your equation should be your x equals whatever with a box around it. So this says you should always check your solution. You will know immediately whether your solution is correct or not. Now we're looking at textbook page 528. So at the top it says a male gorilla weighs 379 pounds on average. This is 181 pounds more than the weight of the average female gorilla. Remember, more than, less than, greater than, fewer than. You want to switch that order. And so they actually have done something a little different here. But anyhow, we've got the 379 and the 181, so let's go ahead and put this in a bar diagram. So as you can see, I went ahead and put an X through the diagram that they have, just because I want to make sure that I'm consistent with you and that you get a consistent message. So the first thing that you want to do is see if you can identify the total. So it says a male gorilla weighs 379 pounds. So what that means is that the total that we're going to be comparing it to is the 379. So you'll see it right here. And as you can see, I went ahead and put color-coded boxes around what we're looking at here. So the first thing that I wanted you to notice was the more than, as well as the total. Now, when you're looking at a word problem like this, you see the 379 right up there by itself, and it just says a male gorilla weighs 379 pounds on average. When you see a sentence like that, and it's just a sentence, that's a good indication that that one is going to be the one that's got the total in it, because notice it didn't give you a total there. So now you're going to say 181 pounds more than the weight of the female. So that means we're going to put the weight of the female right here, and I'm going to go ahead and draw a line right here. And it's going to be 181 pounds more than the weight of the female. So now you can see that we're going to come up with the equation, and I'm going to go ahead and mark this out here because I don't want you to use this at all. So you can go ahead and mark that out as well. Normally I'd ask you not to, but you can. So now you're going to have 379 equals, and actually let's go ahead and stop. Let's write the equation a little backwards. All right, so right down here on the left, we're going to write W equals W plus 181 is going to be equal to 379. So that's the equation that we're going to work from. So we're just going to... So I just went ahead and blacked out the pieces that were there just because I don't want it to be confusing for you. So now we're going to work in reverse. We are going to say what's being done to the W. Well, 181 is being added to it. Oops. Sorry about that. 181 is being added to it. So to undo adding 181, we're going to subtract 181 from each side. So we're going to subtract 181 and 181. All right, so now you can see that I finished working out the problem. We got W equals 198, and I've also done the check out to the side in white so that you could see that. So you want to make sure you have all of that written on your paper and that you have crossed out the information that I've crossed out here. All right, you made it. You've done so great so far. So some reminders before I talk to you a little bit about your homework assignment. It says to show each step. Please do not forget you need to show me each step, just like I've talked about in the video. You want to check your answers. You need to put a box around your answer. So you want to make sure that if you don't have space to do that, because for 3 and 4 you might not, that you add either a large sticky note or even some lined paper right there that you've stapled into your notebook. Either way, you want to make sure that the most important thing is that you show me the inverse operation on both sides, your final answer is boxed, and you have a check. You should have enough room there for 1 and 2, 3 and 4 you may not. But just as a little bonus for sticking with me so long in this video, I'm going to change your homework and I only want you to do numbers 1 through 4. So good luck, and I can't wait to see you tomorrow.